We will talk about the product that I'm actually working for 2 years. So is the Affinidi SDK, so is the SSI SDK. So actually, if you will go to the SDK itself, on our GitHub, you will see that we support browser, React Native Expo, React Native, Node.js. So it's a cross-platform SDK that's written on the TypeScript, and the core is shared. So we massively reuse the code if possible across the platforms, and in a core it's a hidden gem that actually explain all the SSI flows that we support, all the type of credentials, and today we will mainly focus on quite simple part. So how to create a new wallet and what actually happens when we create a new wallet. So it's the my main goal for today, and it's extremely simple. So let's begin. So to create, first of all, you could play with this IPython notebook. Yeah, IPython, but it's support different languages. As you could see, it supports the JavaScript here too. It's the SOS script of scripts. And to run this, you need to pre-install some Node.js packages. So the most important, as I mentioned, it's our SDK for the wallet, and two others is optional for this demo. So, and when you complete the pre-installation and you follow the guide how to run this notebook, if you really want, we could focus on the what actually happens when we create the wallet. And it's one of the problems that I find the name wallet quite confusing. So in the real life, what happens that you store the credit cards, money, identity cards in your wallet, and any crypto wallet have one and the most important function actually. It's manage and give you the access to your private key and public keys. So in case of the different blockchains, it's your public address, yeah, and the state of your account. But I see wallet more as the key manager and signer. So it's manage your private key and use your private key to sign your VC transactions, GVT tokens, or any other things. So, and the majority of the crypto wallets, as I already mentioned, focusing on your account. Affinidi Wallet is more focused on your VCs, VPs, and the SSI entities and your SSI identity. So we will talk about this more. So to get started with our SDK, it's super simple. You need to import the create wallet function. And then create the factory with the arbitrary name that we'll use for some analytic things. And that's it. But first you need to obtain the API key. So to obtain the API key, you could go to our developer's website, register a new account, and at the end of the registration, you will get the API key hash. I will not repeat this procedure, so it's quite obvious. And just give it a try. When you have your API key, you could enter it here, execute the cell, and now we could actually create the options that needed to create our wallet. So we specify that we want to use the production instance of our services and actually specify the API key hash. So, and that's it. It's all options that we need, but on practice, these options quite rich and could configure what kind of DAD methods you want to use, what kind of extra encryption keys you want to use, and so on. So, but it's rather complex. Right now, it's a good start that you just specify your API key and this environment that is production. So the next thing that you need to create the wallet, you need a good strong password. and our SDK will take care about the strong passwords. So if you will provide the weak password, it will fail. So you need at least 8 characters that have the capitals, small letters, numbers, and special characters all together. So please, I know that it's hard, but select a really strong password for your wallets. And here we go. So it's super simple. We get the factory and we use the create wallet method that use the options and our password, and then we will get back the instance of the SDK. So we could say that it's just the wallet. And you get back to super important parts. First important part is the encryption seed. Please keep it secret. Do not share it with nobody. It's actually the part that together with your password allow you to actually recreate your wallet or unlock your wallet. You will see it later how to do it. And the public part is your DID or decentralized identity. This part you will share publicly a lot. You don't need to store it. We will actually give you as a property as you see in a wallet, so it's accessible every time when you unlock your wallet. Actually, it's my demo DID. It's super long, so we used an unencoded LM, so we don't need to pay any extra money for any kind of chain to host it. But what actually happens when we create the wallet, and why encryption seed is super important, and how we generate your keys. So let's go deeper to some sweet technical details. So what actually happened that our wallet is classical hierarchy deterministic wallet. So it's implement BIP32 standard. So it means that we generate all your private and public keys, public addresses in a network just based on some entropy, so called the seed. So it's the quite simple concept. You need only seed to recreate your wallet, and we never expose the seed and private keys outside the wallet. So what we expose is encrypted seed. So, and we encrypt the seed with your password and some special magic, and it's make your wallet then more secured. So if you will take a look, what happens here, that user provides some metadata about the keys and to the seed generator. In the same time, we have our random generation module that generate us 32 bits of the entropy. So as a result of combining the metadata and the password, we produce the seed. And this seed goes to the encryption module that use your password and give you back your encrypted seed that you will always use for unlocking the instance of the SDK and unlocking your wallet. But what happens then? We get the metadata and the seed that we generate and go to the BIP32 model that actually use different derivation passes, depends on the metadata, to generate your public keys, your private keys that we will never expose directly. And then these keys goes to the D document generator that actually generates us the DID document that together with our private keys we will put to the registry, and depends on the metadata and what kind of DID method you use, we actually will produce the DID, this long magic strings that you will get as a parameter on the SDK. So all this complex flow is the process of creation your public and private keys, and set it up the seed to allow to manage it in a future. So let's imagine that you need to unlock your wallet with the encryption seed and password, and it's super easy. As you could see, we do the same. We create the factory. Then we just call open wallet with encryption seed, put the parameters, the options, they are the same. Then we specify the encryption seed and the password, and we get the DID back. And if you will take a look, the DID from the SDK and the DID from the creation will be the same DID. So it's completely the same identity. So what the DID magic mean? So DID is the decentralized identifier. So it's always URL or URI like identifier that could be resolvable. So it's if you will take a look at the structure of this magic string, what we will do that we always will have the schema, and this schema will be equal to the DID. Super important to understand, we have the DID method. Actually the method control how we could do the operations with the DID. For example, super important operation is the resolution of the DID, and then we will have the identifier that actually describe the DID itself. And for example here what we will do, we will grab our DID and try to parse it. So it's the standard library that work with the DID URIs, and as you could see, our DID is this magic string, DID method is the DID element, and identifier actually is this string after the semicolon. So to obtain our DID document or other public keys, we need to do the resolution of the DID. So for this, we could use our registry service that we expose. So it's the part of the core services that used by SDK, but on any time you could go to the service and actually specify your API key in a header and the DID document in a body, and you will get back the DID document. So as you could see, you have your public keys here, and you have actually two public keys. You have the sign-in public key that will be used for verification of your signatures, and you have special recovery key that actually will be used of modifying this DID document in the future. So just to recap, that the main function of the wallet actually is just keeping your secrets and actually create your identity as the decentralized identity that helps you to distribute your public keys and do the verifications of the signatures, and for the signatures you use your private key, and actually it's the main function of the wallet. In my next videos, we will talk more about how to do the operations with the VCs, how to sign the VCs, and how to do more fun with our SDK.